This is Dr. Hussein Abdul Jabir. Inshallah, today I will give you part 1 and the first 4 sections of part 2 of block 3 in course T325, Mobile Evolution. The outline of the first part consists of the following topics. So, the first topic is introduction, the second topic is mobile and nomadic, and the third one is what price data, and finally mobile generations. Introduction, mobile broadband. What is the meaning of mobile broadband? It is high data rate connection to mobile or wireless devices. It is always on high data rate. For example, the data rate is greater than 300 kilobits per second, also considered slow by many fixed line broadband users. Small latency. What does latency mean? Latency is the time taken by data packets to reach their destination or to make a round trip. The latency is less than 200 milliseconds, and it can be reduced to a few tens of milliseconds by applying the improvements to the technology. Services and devices depend on wireless broadband to the end user will become ubiquitous. What does ubiquitous mean? Ubiquitous means to be able to do everything outdoors on mobile that can be done at home or in the office with a static computer and fixed broadband connection. For example, download files, watch videos, checking email, play online games, and so on. Let's now talk about mobile and nomadic. There are two approaches, and these two approaches are mobile and nomadic, that can be used to provide wireless broadband connections for people on the move. Let's now talk about the first approach, which is mobile approach. So again, the first approach is mobile approach, which developed from voice-based telecommunications, where else the second approach is nomadic approach, which developed from wireless local area networks for computers such as Wi-Fi network. Mobile data communication is often used instead of loosely to cover both approaches to wireless communication. We have a question now: how can we distinguish between mobile and nomadic communication? So we can distinguish between them based on technology and also based on legacy and business orientation. Mobile approach. The mobile approach uses cellular wireless networks. Let's assume a huge geographical area. To achieve wide geographical coverage area, we split the geographical or let's say the huge geographical area into a number of cells, and each cell is served by a single base station. We have a question here: what is the size of every cell? The size of every cell is normally several kilometers across. However, in urban areas might only be a few hundred meters across. Okay, now let's talk about the normal business relationship with customers in the mobile approach. This relationship is based on the subscription, which is based with differentiation between the services offered to the subscribers, and these services could be voice, text, and data, and every subscriber will pay different fee based on the services that he or she received. That's why it is called variable charging. The cellular phone system is developed to allow users to continue phone calls without any interruption as they pass from one cell to another, possibly at high speed, for example on a train. Let's consider an example. Assume yourself are traveling from city to another and there are intermediate cities between the two cities. Once you pass a city, then your phone call will pass from cell to another. Nomadic approach. Normally, nomadic approach uses Wi-Fi technology, which is based on the IEEE 802.11 A, B, G, and N standards. In nomadic approach, the geographical area served by a Wi-Fi point that is normally only tens of meters across. If we compare nomadic approach with mobile approach in terms of the relationship with customers, we found nomadic approach is loser, since subscriptions are normally available with operators, but these tend not to be differentiated by services available. In nomadic approach, there is no mobility management because the nature of the services provided in nomadic approach. Mobile and nomadic. Looking to the future, the nomadic and mobile approaches arise to be converging. For example, cellular mobile data communication is expected to be developed by using an initiative called long-term evolution, in short LTE, to networks, and these networks will offer higher data rates and shorter latencies. In terms of the nomadic approach, it is expected to be developed using WiMAX to a system that can offer Wi-Fi like data rates but over longer distances than can currently be served by Wi-Fi. WiMAX stands for Worldwide Interoperability for Microwave Access, where else Wi-Fi stands for Wireless Fidelity. If you want to make WiMAX available over a huge geographical areas, this will require a system of base stations and cells similar to those used in the mobile approach, and also a similarly wide slice of electromagnetic spectrum. Let's now to talk about what price data. Here it is a characteristic feature of the way the mobile telecommunications business model has developed, and this can be done through a careful differentiation of services and also the development of elaborate pricing structures based on these services. Here the difference is not at a pure technical level. The services are differentiated in the customer's mind. Therefore, there is a scope for pricing them according to their value to the customer. What price data in United Kingdom? For example, with a particular cellular operator, £10 can buy one of the following. You can buy in £10 up to 1 gigabyte and data download, or you can buy up to 200 minutes of phone calls, or you can buy up to 200 short message service text messages, and in each message you can write 160 characters as the maximum number of characters per message. We have a question now. What is the cost per megabyte in each case? So in order to find out the cost per megabyte in each case, let's start by the first case, which is the mobile broadband case. The user can upload and download data, but as with a symmetric digital subscriber line, in short ADSL, which is the usual form of fixed line broadband, the upload data rate is much lower than the download. In this case, we will ignore the upload data and we will focus on download data. 1 gigabyte is equal to 1024 megabytes. So the cost per megabyte is equal to 10 pounds divided by 1024 megabytes. We can say 10 pounds equal to 1000 pence. This means we can say 1000 pence divided by 1024. This will give us 0.98 pence per megabyte. Again, to calculate the cost per megabyte here, we will divide 1000 pence by 1024. Then the result will be 0.98 pence per megabyte. In case of phone calls, every phone call occupies a channel in each direction, and every channel has a notional rate of 12.2 kilobits per second. Therefore, for 200 minutes, the amount of data that could be transferred is equal to 2 times 200 times 60. Why times 60? Because we want to convert from minutes to seconds. Times 12 times 1000, result will be in bits 2.928 times 10 power 8. If you want to calculate the result in bytes, we will divide the result in bits by 8. Then the result in bytes equal to 36.6 times a million bytes. Then to find out the result in megabyte, we will divide the result in bytes by 1024 squared. Then the result will be in megabytes equal to 34.9. Therefore, the cost per megabyte is equal to 10 pounds or 1000 pence divided by 34.9. Then the result will be 29 pence per megabyte. In case of SMS text messages, we mentioned previously that we can use up to 200 text messages, and in every text message we can write 160 characters as the maximum number of characters in each message. So each character represents 1 byte or 8 bits. Then to find the result in bytes, we will say 200 times 160. Then the result will be 32,000 bytes. Again, in order to find out the result in bytes, we will multiply 200 with 160 to get the result 32,000 bytes. Then, in order to find out the result in megabytes, we will divide 32,000 bytes by 1024 squared. Then the result will be in megabytes 0.0305. Therefore, the cost is equal to 10 pounds divided by 0.0305. Then the result will be almost 330 pounds per megabyte. Voice over IP calls made over a mobile broadband link could be cheaper than those made using the normal mobile phone protocols and could therefore threaten a mobile operator's major income stream. Mobile generations. Cellular mobile communications technology has been developed through a number of generations, and these generations, for example, first generation, second generation, and third generation. First generation, in short, 1G, and it is analog cellular telephony, whereas second generation, in short, 2G, and it is digital transmission. And also the second generation was initially primarily a voice center technology, but refinements were developed to improve data communication. There are informal intergenerational descriptors such as 2.5 generation, in short 2.5G, and also 2.75 generation, or it is abbreviated by 2.75G, and those have shown for developments that are not considered radical enough to count as a new generation. 2.5 generation equals to GSM plus GPRS. GSM stands for Global System for Mobile Communications, and GPRS stands for General Packet Radio Service. And in 2.5 generation, the data rate is low, and it is around 50 to 70 kilobits per second. In 2.75 generation, further enhancements, let's say adaptations, applied to second generation in order to give higher data rates. Mobile broadband starts with third generation, and it is potentially providing data rates that can be reasonably be described as broadband, such as 384 kilobits per second. The terms first generation, second generation, and third generation do not refer to any particular technology. The technologies used for second generation, for example, can be differentiated, let's say, can differ, especially between the USA and the rest of the world. Even you adopted the similar technologies, this will not guarantee provide you the compatibility. To implement particular technologies, this implementation can be decided by standardization bodies or is a proprietary commercial decision. Okay, we can note in this figure, on this slide, different countries around the world use several technologies in second generation and 2.5 generation and 2.75 generation and third generation and beyond the third generation. Let's start by the first country, which is Europe. For second generation in Europe, they used GSM, and the access technology was TDMA. TDMA stands for time division multiple access. In 2.5 generation in Europe, they used GPRS with the access technology TDMA, and in 2.75 generation in Europe, they used EDGE. EDGE stands for enhanced data rates for GSM evolution, or enhanced data rates for global evolution. And the access technology was TDMA. In third generation in Europe, they used UMTS. UMTS stands for Universal Mobile Telecommunications System, and the access technology was wideband code division multiple access. Then this leads to HSDBA. HSDBA stands for high speed downlink packet access, and this leads to HSPA, and this stands for high speed packet access, and this leads to HSPA plus, and this stands for high speed packet access. Again, HSPA plus, this one stands for high speed packet access plus. Beyond the third generation in Europe, they used LTE, and as I mentioned before, LTE stands for long-term evolution, and this with the access technology OFDMA, and OFDMA stands for orthogonal frequency division multiple access. And also they used WiMAX, and again WiMAX stands for worldwide interoperability for microwave access, and again the access technology here is OFDMA. In Japan, in second generation, they used PDC. PDC stands for Personal Digital Cellular, with the access technology TDMA, and it is like DAMPS, and DAMPS stands for Digital Advanced Mobile Phone System. And also in Japan, in second generation, they used code division multiple access one, like IS-95. IS stands for Interim Standard. In Japan, in third generation, they used wideband code division multiple access, and beyond the third generation in Japan, they used the same technologies used in Europe. Okay, in USA, in second generation, they used DAMPS, IS-54, IS-136 with the access technology TDMA, and also in second generation in USA, they used IS-95 with the access technology code division multiple access, and for 2.5 generation in USA, they used code division multiple access 2000 with the access technology code division multiple access, and for the third generation in USA, they used code division multiple access 2000 AVDO. AV stands for evolution, and DO stands for data optimized. And in USA, in second generation and 2.5 generation and 2.75 generation, they used the same technologies used in Europe. And for third generation in United States of America, they used wideband code division multiple access, and beyond the third generation in USA, they used the same technologies used in Europe. In South Korea, in third generation, they used TTA1 with the access technology wideband code division multiple access, and they used TTA2 with the access technology similar to code division multiple access 2000. And beyond the third generation in South Korea, they used the same technologies used in Europe. In China, in second generation, they used GSM. Again, GSM stands for Global System for Mobile Communications with the access technology TDMA. And in third generation in China, they used possibly TDS CDMA, and this stands for Time Division Synchronous Code Division Multiple Access. And beyond the third generation in China, they used the same technologies used in Europe. In India, in second generation and 2.5 generation and 2.75 generation, they used the same technologies used in Europe. And in third generation in India, they used wideband code division multiple access, and beyond the third generation in India, they used the same technologies used in Europe. Okay, Let's now to talk about part 2. Let's say the first 4 sections in part 2. Part 2 here, network architecture. The outline of part 2 are following topics: introduction, key terms, network elements, and final evolution from second generation to third generation. Introduction, network architecture. What is the meaning of network architecture? Network architecture means the way in which the required functions of the network are allocated to distinct physical network elements, sometimes referred to as nodes. The nodes can be geographically separated, for example, base station and base station controller. Architectural divisions of a mobile network. What are divisions of a mobile network? Architectural divisions of a mobile network are the following: access network, core network, and finally user equipment. Let's start by access network. Here the purpose from the access network to give users access to the core network, and the access network consists of the following: base stations and base station control nodes, which are the elements that immediately control the base stations, and the access network consists of their associated wireless technologies. Core network and user equipment. Let's start by the core network. A core network is largely a fixed communication network. A core network can perform several functions such as authenticates users, routes data and calls, works out, etc. The core network employs many communication technologies, including fixed microwave links, wire, fiber. Okay, let's now to talk. And it is abbreviated by UE. Consists of the mobile devices used by the subscribers. For example, the user equipment can be a mobile phone or personal digital assistant, or let's say PDA. Signaling and user traffic. For any network, either mobile or fixed, it is normal to consider the structure and operation of the network from two perspectives. These two perspectives: signaling and user traffic. What is the meaning of signaling? Signaling means the protocols used to set up the services for the user and also to manage the network, or let's say we can use it to manage the network. Examples on these could be the message sequence required to set up a voice call. We have a concept here called control plane. What is the meaning of control plane? Control plane means the view of the network which describes the signaling protocols. The other aspect of the network is the user traffic. Examples on the user traffic are video streaming data, discrete downloaded data blocks, voice call data, etc. We have another concept here called the user plane. What does user plane mean? The user plane means the view of the network which describes the protocols for the transmission of the user traffic, data transmission. How can we transmit data in a digital network? First of all, A digital network could be fixed or mobile. In order to send data in a digital network, there are two basic ways, and these two ways are circuit switching and packet switching. So let's start by the circuit switching. In order to transmit data in a digital network, we can use circuit switching. It derives its name from earlier telephone technology. In circuit switching, a conducting circuit was established between caller and person called for the duration of a call. In circuit switching, the participants had exclusive use of this resource for the duration of the call. Now let's talk about packet switching. Packet switching enables the communication resource, for example, fiber or a cable or a wireless link, to be shared between several users in such a way that allows to each user to possibly access to the communication resource, and there is no user has exclusive use of it. Data of users can be split into packets, and the network is structured as a series of lines interconnected by routers. These days, telecommunication networks can carry different types of data, not just voice, and can use both of packet switching and circuit switching. We have a concept here called session. What does session mean? First of all, the concept of a call has accordingly been generalized to a session. A session means an organized exchange of data between two or more users, which can be of many types, such as a video link, but it includes a straightforward telephone conversation. We have a concept here called the Session Initiation Protocol, in short SIP. What is the meaning of the Session Initiation Protocol? It is a way of setting up and managing sessions that is becoming widely used. Mobile radio users can be regarded as mobile or nomadic. Networks can be split into two classes, and these two classes are nomadic networks and mobile networks. And this split depends on whether or not the architecture supports continuous sessions with the mobile device as it moves around. Nomadic and mobile networks. Nomadic networks. In a nomadic network allows the user to log on to the network whenever it is within radio coverage of the network. If the user later on moves to the coverage area of a different radio transmitter, then the session is terminated and the user has to log on again. For example, on nomadic networks, network based on Wi-Fi or fax. Let's now talk about mobile networks. A mobile network maintains a continuous session as the user moves around by handover operations, or a handover operation here. A handover means that a session can transfer from a cell to another. Mobile networks need to be able to track the location of the user's mobile, aiming to be able to send data to the mobile and also to set up incoming services. This function is called mobility management. We have a concept here called authentication. What is the meaning of authentication? Authentication means the ability to validate a mobile device requesting a connection. We have some concepts here need to be known. Let's start by the first concept, which is downlink. Downlink are the transmissions from the base station to the mobile. The second concept here is the uplink. Uplink means the transmissions from the mobile to the base station. The third concept here is duplexing. Duplexing means of separating the transmissions in either direction in order to prevent them interfering with each other. There are two principal duplexing techniques that are used in networks of mobile and nomadic. The first technique is frequency division duplexing, in short FDD. The signals of uplink and downlink in this technique can be transmitted simultaneously but on different frequencies. The second technique called time division duplexing, in short TDD, and in this technique the signals can share the same frequency but are transmitted at different times. User equipment, in short UE. It is another name for mobile devices such as mobile phones, personal digital assistants, or in short PDAs, and data cards, whether built-in or external for laptop computers. Every user equipment comprises two principal components. The first component is the phone or personal digital assistant, or in short PDA or data card. The second component is removable smart card, and it is known as the SIM card. SIM stands for subscriber identity module. In third generation networks, the SIM card is named by the UMTS SIM card, or in short USIM card. This is the SIM card. Okay. The mobile device contains all and software required to interface to a mobile network, provide the interface to the user. Every SIM card contains from the following information. First of all, the key user information required to enable the mobile device to authenticate to the network. The SIM card also can contain other user information such as contact lists and text messages received from other users, and also the SIM card contains and stores a 4-digit personal identification number that can be used to prevent unauthorized users from accessing the personal information stored on the SIM card. We have a question here. Why to separate the functions of the SIM card from the mobile phone? The answer of this question consists from 2 points. The first point is to increase the degree of competition between the mobile network providers. For example, if you want to change your mobile phone, you can buy a new one, but you do not change your mobile network provider. The second point is, assume yourself traveled to a foreign country and you want to make phone calls. You can buy a local SIM card phone calls, because if you use your home network, this will impose you to pay extra money as a fee for these phone calls. Radio access network. The user equipment can communicate with the radio base stations over the radio interface, or let's say air interface, using a frequency band exclusively allocated to a particular operator. In the second generation standards, we name the base stations by the base transceiver stations, or in short BTSS, while in the third generation standards we name the base stations by the node BS. In the third generation standards, the radio access network is also known as the UMTS radio access network, and it is abbreviated by UTRAN. In the second generation standards, the element that control the base stations is named by the base station controller, in short BSC. Where else in the third generation networks, the element that controls the base stations is named by the radio network controller, or in short RNC. In this figure, on this slide, we can note 4 cells, and in each cell the user equipment can connect to the one of the base station. For example, in second generation networks, the user equipment can connect to the base transceiver station, where else in the third generation networks the user equipment can connect to the node B. Okay, in second generation networks the base stations are controlled by the base station controller, where else the base stations in the third generation networks are controlled by the radio network controller. The base station controllers and the radio network controllers can connect mobile switching center, which is abbreviated by MSC, and the mobile switching center can connect to other mobile switching centers, and also can connect to a fixed telephone network, and also can connect to other base station controllers and radio network controllers. Evolution from second generation to third generation. In the second generation standards, the user equipment is known as the mobile station, or in short MS. The access network in second generation standards consists of the base transceiver stations, again base transceiver stations and the base station controller. The core network in the second generation standards can be explained as follows. Each mobile switching center either switches calls between users within the area covered by its base station controllers, or routes them to other mobile switching center for onward routing within the same network or outside the network. One or more of the mobile switching center can be used to interface to fixed networks, and this includes interconnections with other mobile networks, and this role is called the Gateway Mobile Switching Center, or in short GMSC. Okay, here this is the second generation network. This part is the user equipment, and as we mentioned previously, the user equipment in second generation standard named by mobile station, or in short MS. The user equipment can connect to one of the base stations in the radio access network over a radio interface, and here in the radio access network we can note that the base station controller can control the base stations, and the base station controller can connect to the mobile switching center or visitor location register in the core network. In the core network, the mobile switching center or visitor location register can connect to the gateway mobile switching center and also can connect to the EIR, where EIR stands for Equipment Identity Register, and also mobile switching center or visitor location register can connect to home location register, and the home location register can connect to AUC. AUC stands for Authentication Center, and also home location register can connect to Gateway Mobile Switching Center. And here finally, the Gateway Mobile Switching Center can connect to public switched telephone network. Okay, I just want to mention that the EIR, HLR, and AUC, we did not yet explain them. Inshallah, we will explain them in the next slide. Okay, here below the mobile switching center, we can note 3 key support elements, and these elements are the Equipment Identity Register EIR and the Home Location Register HLR and the Authentication Center AUC. Let's start by the Equipment Identity Register EIR. It is used to track the identity of physical mobile devices and also can be used to bar access by stolen devices. Home Location Register is used to hold the master record of each mobile user, and it is used by other network elements in order to check whether access to a given service should be granted or not. The Authentication Center AUC is used to store the keys required for authentication. The Mobile Switching Center also includes another function named by the Visitor Location Register, or in short VLR. The Visitor Location Register can work together with the Home Location Register to maintain a record of the current location of each mobile device. In order to set up incoming calls to mobiles, the network needs to know the location of the mobile down to the individual cell level. We have an issue here, which is what is the frequency of cell location update. Okay, we can say continuous cell location update implies high levels of signaling traffic, implies drain the mobile's battery. Mobile location update. The network can be split into larger areas known as location areas, in short LAS. When the mobile has no calls in progress, it reports only on a change of location area and not changing the cell. Okay, in order to minimize signaling traffic on the core network, we can use a two-level process that can be used to track the location of the mobile. The first level is the Home Location Register, contains the details of the users and also the address of the Visitor Location Register in whose area the mobile is currently situated. The second level is the Visitor Location Register, contains a record of the location area and also the last known location of the cell of the mobile. We have a concept here called paging, What is the meaning of paging? In order to contact the mobile, it is necessary to send out a message to all the cells in the location area in order to invite the mobile to reply. Okay, we have a question here. Is the location area size too small or too big? If the answer is too small, then this size leads to high signaling traffic. Where else, if the answer is too large, then this size will result in an unacceptable level of paging traffic, given that paging messages should be sent to all the cells in the location area whether the mobile is there or not. We need to make a trade-off in location area size. (2.5) generation, adding packet switching. In order to add the ability to transport IP packets across the GSM radio network, this can be done through the addition of two new elements to the core network. The first element is serving GPRS support node, or in short SGSN. The second element is gateway GPRS support node, and it is abbreviated by GSN. Then the result will be the General Packet Radio Service, or in short GPRS, and this is also known as 2.5 generation, or in short 2.5G. So as we mentioned previously, we need to add the two elements, and these elements are serving GPRS support node, which is abbreviated by SGSN, and gateway GPRS support node, which is abbreviated by GSN, in order to add the ability to transport IP packets across the GSM radio network. Migration to third generation. This is required in new mobile devices, known in the third generation standards as the user equipment, or in short UE, and also the addition of the third generation radio access network. The Node B provides the same functions in third generation as those provided by the base transceiver station in the second generation. The radio network controller provides the same functions in third generation as those provided by the base station controller in the second generation. So Node B and radio network controller are in the third generation, and base transceiver station and base station controller are in the second generation. The radio network controllers, unlike the base station controllers, since the radio network controllers have a peer-to-peer interface, that means they can communicate directly with each other, and also this interface can be used to coordinate handovers between the Node BS, and also to reduce the workload in the mobile switching center or serving GPRS support node. Okay, let's explain the third generation network here. In the user equipment part, we name the mobile device by the user equipment, or in short UE. and the user equipment can connect to one of the base stations in the radio access network over a radio interface, and the radio network controller in the radio access network can control the base stations, and a radio network controller can connect to the mobile switching center or visitor location register of the core network in the second generation network, or can connect to the serving GPRS support node in the core network of the third generation. Here the base station controller can connect to the serving GPRS support node in the core network of the third generation, and we can note mobile switching center or visitor location register can connect to serving GPRS support node, and also mobile switching center or visitor location register can connect to EIR, and here serving GPRS support node can connect to EIR. Mobile switching center or visitor location register can connect to home location register. Similarly, serving GPRS support node can connect to home location register. Home location register can connect to authentication center and also to gateway mobile switching center and also to gateway GPRS support node. Here serving GPRS support node can connect to gateway GPRS support node, and finally gateway GPRS support node can connect to internet and corporate IP networks. Thank you for your listening. Wassalamu alaikum wa rahmatullahi wa barakatuh.